Okay, good afternoon. Now we will be solving page 107, number 37. Okay, we are tasked to evaluate the following differential equations: y triple prime plus 5y double prime plus 9y prime plus 5y equals 3e to the 2x. Now, as you can see, we have a exponent of exponential function here. So the method that we are going to use is the method of undetermined coefficients. This would be the best method since the differential equation contains this kind of function, and when we integrate and when we differentiate this repeatedly, it will just produce a finite number of integrable functions. So with this function, we can use undetermined coefficient and then solve for the following solution of this higher order dx. Now let's start. We make some necessary substitutions. We let y be equal to e to the mx. Now when we differentiate this, we get y prime equals m e to the mx, and then we get y double prime equals m squared e to the mx, and then y triple prime gets m cubed e to the mx. We're going to substitute these values here to the differential equations that is given, and then solve for the roots of m. Now, substitute. This is the original differential equation: triple prime plus 5y double prime plus 9y prime plus 5y equals 3e to the 2x. When we substitute and then factor out the e to the mx, we get m cubed plus 5m squared plus 9m plus 5 equals 3e to the 2x. Since we are looking for the complementary solution, we have to first equate this expression here to 0 to solve for the complementary solution of the homogeneous differential equation. Since this is a non-homogeneous, we have to equate this first with 0, and we have to solve the roots of m, for which this equation will be equal to 0, and then we use some necessary substitutions to find the particular solution of a certain differential equation. Now, when we get the roots of m cubed plus 5m squared plus 9m plus 5 equals 0, we have one real root and then two imaginary roots. We have m1 gets equal to -1, and then your second root is equal to -2 plus I, and then m3 is equal to -2 minus I, identifying that alpha will be equal to -2, and then your beta will be equal to 1. Okay, so according to the case 3 of the rules, we get this following expression: y complementary is now equal to y complementary is equal to c1 e to the minus x, which is the root of the first root, plus e to the minus 2x, this is the alpha, times the quantity of c2 sine beta x, which beta is equal to 1, so this is x, plus c3 cosine of beta x, also equal to 1, and that one. That is now our complementary solution. Now the lacking part is the y particular, since we are dealing with a non-homogeneous differential equation. Now in dealing with a non-homogeneous differential equation, according previously we have mentioned that we will be using undetermined coefficients. So when we talk about undetermined coefficients, we are going to have an educated guess about the form of our particular solution. Since the solution we have had is y triple prime plus 5y double prime plus 9y prime plus 5y is equal to 3e to the 2x, we identify that the function here is equal to 3e to the 2x. Now we have to have a y particular form, and say we get this guess as a e to the 2x. Okay, yp is equal to a e to the 2x, and then we integrate, we differentiate this one thrice and then twice and then one, then substitute this one to the given differential equation and equate this to the function, and then we determine the coefficients. Okay, that's all. We have yp equals ae to the 2x, then yp prime is equal to 2a e to the 2x, yp double prime is equal to 4a e to the 2x, yp triple prime is equal to 8a e to the 2x. Then we substitute this one to the given differential equation and equate both to the function f of x and determine the value of the coefficient a. We have 8a e to the 2x plus 20 a to the 2x plus 18 a e to the 2x plus 5a, this is 5a e to the 2x equals 3 e to the 2x. Then we add and we get 51 a e to the 2x equals 3 e to the 2x. Notice that this expression will just be equal when the coefficients of e to the 2x will be equal. So 51a is equal to 3. Then solving for a, we get 3 over 51. Now we have the form of our y particular, since we already solved the value of our undetermined coefficient. Now to summarize, we have the form of our particular solution as being y particular is now equal to 3 over 51 e to the 2x. Then by principle of superposition, we get the complete solution of the given differential equation, including the y complementary, which was previously solved, which is c1 e to the minus x plus e to the minus 2x times c2 sine x plus c3 cosine x plus the value of your yp, which is equal to 3 over 51 e to the 2x. This will be now the complete solution of your given differential equation.